To find a solution to a system of equations, you're looking for the point where the two lines cross, or another way to state it is the ordered pair, the x and y value, that makes both equations true. So in this situation, we have one of the equations is already solved for one of the variables. It's solved for y equals. So in this case, we're going to use substitution because we can substitute what we know y to be according to this equation. We can turn around and substitute that for y in the other equation and solve for x. So let's see how that works. We've got 7, but instead of y, I'm going to just put parentheses, and I'm going to put this entire thing into the parentheses. So I'm going to put negative 17x plus 13. So that's my 7y equals 28x minus 112. And then I'm just going to solve this equation for x. So I've got 7, I'm going to have to distribute it times both of the values inside the parenthesis. So 7 times negative 1/7 is negative x. And 7 times 13 is plus 91. And that equals 28x minus 112. Now I'm solving for x. I'm going to go ahead and subtract. I'm going to move my x's to the left, so minus 28x. Bring that down. That gives me negative 29x plus 91 equals negative 112. I'm going to subtract the 91 from both sides, and my 91s cancel out, leaving me with negative 29x equals negative 203. And then my final step is to divide both sides by the negative 29, and I get that x equals 7. So now I have an absolute value, or an actual value for x. So I'm going to go ahead and go back in to my second equation, and I'm going to plug what I know x to be into that equation and solve it for y. So I'm going to take the second equation, and I've got y equals negative 1/7, but instead of x, I'm going to put parentheses and put the value I just figured out, plus 13. So I've got y equals negative 1/7 times 7 is negative 1 plus 13. And y equals negative 1 plus 13 is 12. So my ordered pair, my solution to this system of equations, is 7, 12. The 7 coming from my value of x, and the 12 coming from my value of y.